Review Lesson 1, Equations of Lines. Yesterday we began this lesson by finding the slope of a line passing through 2 points. Today we want to continue with this lesson. We'd like to use the slope-intercept form, y is equal to mx plus b, and the point-slope form of equations of lines to write equations of lines. So we call this the slope-intercept form, and this is called the point-slope form. Our first example is number 36. Find an equation of the line that passes through the given points and sketch the line. So we can begin by finding the slope of the line. We're going to go ahead and use the slope-intercept form, y is equal to mx plus b. So we need to find the slope, and we need to find the y-intercept. If we know these two parameters, we'll be able to write an equation for this line. Write an equation of the line passing through these 2 points and sketch the line. Although it is not necessary for you to plot the 2 points to find the slope, we'll go ahead and do that because it will help us to visualize the line. So we have, let's say we call this point A, and let's call the second point B. So we have -3, -4, -3 for x, -4 for y. So there's point A. And then point B is at the point 1, is the point 1, 4. So there's point B. So here's the line passing through those 2 points. And what we'd like to do is we'd like to write an equation of this line. So we need to find the slope of the line and the y-intercept of the line. It looks like the y-intercept will be 2, but we can make sure that it is. I did this drawing by hand, but it's probably correct. So let's find the slope. So either you can find the slope by using this triangle, this right triangle, and you can count the rise. The rise would be 1, 2, 3, 4, 5, 6, 7, 8. And the run would be 1, 2, 3, 4. So the slope is the ratio of the rise to the run. So it would be 8 divided by 4, or 2. Of course, you could also find the slope by using the slope formula, where you are going to subtract the y coordinates of the 2 points. So you will have 4 minus -4. That tells you the rise. We counted that it was 8 earlier. 4 minus -4 is 8. And then you will find the run by subtracting the x coordinates. 1 minus -3, which gives us a run of 4. And 8 divided by 4 is 2 for the slope. So now we know the slope. So what we can do is we can write y is equal to 2x plus b. So to complete the problem for writing an equation of this line, I just need to find the y-intercept. And this can be done right now by using what we know, which is that the slope is 2, and we have this partially completed, where we have the slope substituted for m, but we need to find b. So what you can do is you can use one of these 2 points. You can use either point A or point B and just substitute for x and y and solve for b. So I'll go ahead and use point B, and I'll substitute 1 for x and 4 for y in the equation that I have. So 1 for x and 4 for y, and I'll solve this equation for b. Subtract 2 from both sides of the equation, and I would get b is equal to 2. As we expected, because you can see that the y-intercept for the graph that I sketched was 2. So we have y is equal to 2x plus 2, and that's our final answer. Our second example for today is number 51. The instructions are sketch a graph of the equation. So the first thing that you need to do is you need to recognize that the given equation is in slope-intercept form. when you recognize that the given equation is in slope-intercept form, you can easily identify the slope of the line to be -2 and the y-intercept of the line to be at y is equal to 1. So if you want to sketch a graph of this equation, your first step is to plot the y-intercept. The y-intercept is 0, 1. So I find the point 0, 1, which is right here, and I plot it. The next step is I need to get a second point that's on this line. And I can get a second point that's on this line by using the slope. The slope is the ratio of the rise to the run. And we know the slope for this particular equation is -2, which you can write as -2 over 1. So how do you use this slope to get a second point? You start at your y-intercept, and then from your y-intercept, you will rise -2 units. If you're rising a negative number of units, you're actually falling or going down. So we'll go down by 2 units, 1, 2, and then we'll go to the right by 1 unit. So we end up here. So that's our second point, and with these 2 points, we're able to sketch our line. So we have completed this problem. We've sketched a graph of the equation by recognizing that the given equation is in slope-intercept form and using the y-intercept to start and then using the slope to get a second point. And now we take a look at the third example for today. Number 59, write an equation of the line through the point. So there is a given point. We want to write an equation of the line that passes through the point 2, 1, and our line should be parallel to the given line in part A and perpendicular to the given line in part B. So we will have 2 separate lines, and we want to write equations of these 2 separate lines. So we need to review something about parallel and perpendicular lines. So here's what we're reviewing about parallel and perpendicular lines. Parallel lines have the same slopes. So 2 lines are parallel if they have the same slope. So for example, the slopes could be 3 and 3, -2 and -2, which would give you 2 parallel lines. Or you could have 0 and 0. You would have 2 horizontal lines, and they would be parallel to each other. Perpendicular lines have slopes that are opposite reciprocals. For example, if the slope of one line is 3 over 4, then the slope of the other line would be -4 over 3. If the slope of one line is -7 over 5, then the slope of the other line would be +5 over 7. If the slope of one line is -11 over 3, then the slope of the perpendicular line would be +3 over 11. So perpendicular lines have slopes that are opposite reciprocals. They have opposite signs, and also they are reciprocals of each other. Parallel lines have the same slopes. With that review, we're ready to go back to our problem for number 59. Write an equation of the line through the given point parallel to the given line in part A. So we need to find the slope of the given line. You can do that by rewriting the given line in slope-intercept form. So we're going to do that. So 4x minus 2y is equal to 3. Subtract 4x from both sides of the equation. So when I subtract 4x from the left side of the equation, 4x minus 4x is 0. So I just have -2y is equal to, and then I subtract 4x from the right side of the equation to give me -4x plus 3. Now I'm going to divide both sides of the equation by -2 to get y by itself on the left side of the equation. So you're going to have to divide negative 4x by negative 2, giving you positive 2x. You're also going to have to divide positive 3 by negative 2, giving you negative 3 over 2. But the important thing is we wanted to know the slope of the given line. The given line has a slope of 2. So when we're doing part A, we would like to write an equation of the line that passes through the point 2, 1, and that would have a slope of 2. There are different ways you can do this problem. One way is to use the point-slope form of the equation of a line. In the point-slope form, m is the slope, and x sub 1, y sub 1, which you see here and here, represent the coordinates of a point that is known to be on the line. So now we may go ahead and write an equation for the line passing through the point 2, 1. So that means that x sub 1 would be 2 and y sub 1 would be 1. So that's those are the coordinates of a point that we know to be on the line. And we also know that we want our line to be parallel to the given line, and since the given line has a slope of 2, our line must have the same slope of 2 to be parallel to it. So with that, we can substitute 2 for the slope. And we can substitute 2 for x sub 1 and 1 for y sub 1. So we're actually done with the problem because all it is stating is write an equation of the line through the given point parallel to the given line. We're done with part A. You do have the option to leave the equation in point-slope form, or if you want to, you can rewrite the equation in slope-intercept form by doing some algebra here. You can distribute the 2 to the x and to the quantity inside the parentheses. So that would give you y minus 1 is equal to 2x minus 4. And then you can add 1 to both sides of the equation, giving you y is equal to 2x. Negative 4 plus 1 is negative 3. And of course, if you wanted to, you could graph this line. You could also graph the original line, and you would see that they're parallel to each other. So we're going to represent what we just did graphically. So the given line is 4x minus 2y is equal to 3. When we write that in slope-intercept form, this is what we get. And when we graph it, this is the graph that we have. So the given point is the point 2, 1, which would be right here. That's the given point, 2, 1. And we found the equation of the line that passes through 2, 1 and is parallel to the given line. And that equation is y is equal to 2x minus 3. And of course, y is equal to 2x minus 3 passes through the point 2, 1 and is parallel to the graph of 4x minus 2y is equal to 3. And in fact, here is the graph of the line passing through 2, 1 and parallel to the given line. And that's what we found. Y is equal to 2x minus 3. So now we're going to take a look at 59b. Write an equation of the line through the point 2, 1 perpendicular to the given line. Earlier, we were able to rewrite our given line in slope-intercept form, and it was written as y is equal to 2x minus 3 over 2. So we know the slope of the given line is 2. So any line that's perpendicular to it will have a slope that's the opposite reciprocal of 2. So 2 can be written as 2 over 1. So the opposite reciprocal would be a negative slope, and it would be negative 1/2. So we can once again start our equation in point-slope form. Because we know the perpendicular line will have a slope of negative 1/2, we can go ahead and substitute negative 1/2 for the slope. And we also know that our line, our perpendicular line, must pass through the given point, which has coordinates 2 for x and 1 for y. So we write that in for x sub 1 and y sub 1. You could stop here because all the instructions are asking you to do is to write an equation of the line passing through the point perpendicular to the given line, and we've done that. You could also convert it to a different form, such as standard form or slope-intercept form. So although it is not required in this problem, we can write this problem in slope-intercept form. One way to do that is to distribute the negative 1/2 to the quantity x minus 2 and then add 1 to both sides of the equation. So we'll go ahead and do that. And we get y minus 1 is equal to negative 1/2 x plus 1. And then add 1 to both sides of the equation. You get y is equal to negative 1/2 x. 1 plus 1 is 2. So this is the equation of the line passing through 2, 1 that is perpendicular to the given line. Y is equal to negative 1/2 x plus 2. So although we were not asked to graph the line perpendicular to the given line passing through 2, 1, we can go ahead and do that. The equation is y is equal to negative 1/2 x plus 2. You can see that the y-intercept is 2, so I'll go ahead and plot the y-intercept here. And the slope is negative 1/2. And again, remember, slope is the ratio of the rise to the run. So if it's negative 1/2, the rise is negative 1, and the run is 2. So from the y-intercept, because the rise is negative, you will come down 1 unit, and the run is positive 2, so you will go to the right by 2 units. And when I do that, of course, I end up at the point 2, 1. And we should end up there because our equation represents the line that passes through the given point and is perpendicular to the given line. And the given line is, of course, in black. And the line parallel to it is in blue, passing through the point 2, 1. And now we're going to graph the line perpendicular to the given line, passing through the point 2, 1 in red. And you can see that the lines are perpendicular. So today in Lesson 1, Part 2, we looked at using the slope-intercept form and the point-slope form of equations of lines to write equations of lines. Vocabulary that you want to know are slope-intercept form and point-slope form.